we're talking about here is where does that crevassed waste go and what happens to it as it's going there and when it reemerges on the glacier on Denali. All of this stems, as Roger said, from the fact that most of the waste is still crevassed on Denali, even though the mountain has been significantly cleaned up by Clean Mountain cans. And this looks a lot like a graph that he showed us a few minutes ago, except I've changed the axis and, to pounds of waste per year. You see the increasing numbers of climbers. And if you just do a rough calculation based on, 2 to 3 weeks on the mountain per trip and, some rough weight of human waste per day, you get something like 243,000 pounds, or let's just say over 100 tons of waste being deposited on the mountain since 1970. And of that, some very small fraction is getting flown off in the Clean Mountain cans, and the rest is staying on the mountain. So just as for those of you who aren't familiar with the mountain, the base camp Roger was talking about is right here. This is the main climbing route up the Kahiltna Glacier. And then shown here in the dots, I focused on this area in the study that I'm going to be presenting. But then there's the rest of the trip to the summit. And it's really just the high camp up here where the Clean Mountain can use is required, and down here at base camp. And so the point I want you to take from this is that everything in between, most of that waste is getting crevassed, and most of the waste from the high camp, or I don't know if we know if it's most, but some fraction of it, the climbers dump it in crevasses on the way down, which is permitted, correct, Roger? Okay, so we got a lot of waste going in the glacier. The question is, what becomes of that? It's a flush toilet. It's a fantastic flush toilet. This is all the accumulation zone of the glacier, and I'm not showing you the I don't even know, probably 40 kilometers of glacier downstream of where people fly in and start their climb. That's where that waste is going, and so it's very effective crevassing the waste in terms of keeping the climbing route clean, but what happens to all that waste further downstream? So the idea is this waste is out of sight, is it out of mind, is it any longer an issue or not? That's the question here. A little quick reminder, this is a glacier in cross-section, and we have an accumulation zone where more snow falls each year than melts, and an ablation zone where more snow melts each year, so we also melt some of the old ice compared to what falls in the wintertime. And then in the middle, the fern line. Most of you are familiar with this. One point I want to make here is that this is a little bit of a unique situation in Alaska and some of the polar regions. Most of the glaciers where we see big climbing activity worldwide, the climbing route also travels across the ablation zone. And in fact, I think in the Himalayas, probably most of the climbing route is in the ablation zone. And so whatever is deposited in the glacier is going to melt back relatively quickly and show up to the climbers. But again, on Denali, everything is happening up here, so no one's really seeing or paying attention to the melt-out zone where the waste might reemerge. And so the idea here is we bury the waste there, but it's going to reemerge in the ablation zone because it's transported downstream and melts out. So the questions we're asking in this study, this is work that the Park Service asked us at Alaska Pacific University to help with, is number one, figure out where is that waste going to melt out in the ablation zone, and when is that going to happen? Is it 100,000 years from now, or is it already starting to happen? That's been the bulk of my work on this so far. I'm a glaciologist, and then Katie's working in her master's thesis on this question, what happens to it? Is the waste biologically active? Are there E. coli and so forth still in the ice after it's buried? Do we see any of that contamination in the runoff in the Kahiltna River? And what is it going to look like when it melts out? Remember, we're talking over 100 tons of waste. So I'm going to try to address the trajectory questions first, and then we'll talk about the fate. I should say that this is work in progress. This is a multi-year project, and we've done a couple years of work, and we have a few more to go. So some of this will be results, and some of it will be our plans. So first of all, the question of the trajectory, we need to know which direction the ice goes, and I'm showing you, apologies for the quality of this topo, the way it came out, but this is the upper Kahiltna here, that main stem, there's base camp, and this is just showing you the trajectories and the velocities of ice that have been measured by myself and by some other folks over the years, including National Park Service workers and some folks from the Cold Regions Research and Engineering Laboratory. So gathering together all the data we can get and seeing where is the glacier going and how fast is it moving. And these are sort of just a summary. The ice along the climbing route is moving, depending on where you are, between 5 and 65 centimeters a day. So, you know, in this zone, that's how much ice we're getting moving a day. Typical, right along the center of the main stem, would be about a half a meter a day of velocity, and that gives us some ability to predict how fast the ice is going downstream. I won't say much about this because it could take more time than I have, but we also need to think about the mass balance of the glacier. This is how much snow is accumulating each year as a function of altitude, and how much melt is occurring each year as a function of altitude. And this is just this is actually pretty crude data, I'll admit, but it's a plot as a function of distance down glacier of what we think the accumulation is and the ablation or the melt. And if you just add those together, you get this mass balance profile. And we need that to understand how fast is waste buried when it's deposited in a crevasse in the accumulation zone, and then how fast does it melt out when it gets down into the ablation zone eventually. Okay, so we put together the velocity of the ice, the speed, and this mass balance profile. And we can make a little model, and this is a movie. It's not going to be nearly as exciting as the one Mike tried to show yesterday at Snowball, but his didn't work. I was sort of glad of that. Anyway, what I'm showing you is this is the result of a computer model where we're going to bury some simulated waste up here. This is elevation high on the climbing route, and watch it be buried and transported downstream and eventually melt out in terms of distance down glacier from Windy Corner. This is just sort of a for example. This is what if waste is buried at the 11,000 foot camp. That's the upper end of the main stem before you go around Windy Corner and get sort of towards the upper mountain. So at 3,360 meters, you crevasse some waste. Our model would predict you'll see that waste again at about 1,000 meters elevation, so quite a bit further down the valley. It's 51 kilometers down glacier. You're not even at the terminus yet, but you're closer. And it's 405 years later, according to our predictions. So, you know, we don't have to worry about it. Our kids don't have to worry about it. Our grandkids don't have to worry about it. Down the line, eventually someone does. But the important thing is that if you bury the waste here, it's not going to get buried nearly as deeply, and it's going to melt out quite a bit quicker. And so it's important to take into account where the waste is being crevassed. And this is a lot of information to digest, but I'm just showing you, here's some of the main sort of camps and locations on the main stem of the Kahiltna Glacier, and just focus on this over here, years to melt out. I just showed you that example. But I want to draw your attention to these numbers down on this end. This is the lower end of the climbing route, and then this is actually a little bit downstream of that where the Park Service has been doing some glaciology research. But these numbers, they're not perfect, but they're in the ballpark of saying we should be seeing this waste melting out on the lower glacier soon, the stuff that was buried lowest on the glacier. So one of the things that we get out of this preliminary work right here is 405 years or out of sight, out of mind, not really. If it's not melting out yet, it's going to be very soon on the lower glacier in an area that very few people travel. And one of the things we want to do is go down there and actually find out, is it melting out yet, so we can characterize it. So these are predictions, and they bring me to the question of, well, what is that stuff going to be like when we see it next? So this is sort of how I frame the question of the fate of the waste, is when in the life cycle of crevassed waste is it a health hazard? And by life cycle, I mean, is it a health hazard when it's put in the crevasse, when it's encased in the ice traveling downstream, or when it melts out on the glacier surface downstream? The things we want to ask about, everyone's heard of these, and we've been talking about them the last few days. I'll draw attention to the others. It's been mentioned a few times that protozoa like Giardia last longer, are more hardy than the things we typically test for, like E. coli and total coliform. And that's a big question I kind of want to put out to this group here. Love to chat with you more about it afterwards. Is who is or who can test for Giardia in the waste, because we're testing right now for E. coli and total coliform, and we'd really like to know, is Giardia persisting in the glacier as it goes downstream? And right now we don't have the means to test for that. We're looking for a lab that can help us. So life cycle, where are we looking? We're looking on the glacier surface where the climbers are traveling. We're looking at the buried waste that's in the ice or the snow. We're looking at the waste when it melts out at the surface. And we're looking at the water in the Kahiltna River. And when I say looking, that means we've either done it or we plan to. So let me just tell you a little bit about each of those, and I'll wrap up with that. This, again, is that sort of main stem of the Kahiltna. There's base camp right there, and these red dots, there's another one, there's another one, there's another one. Those are commonly used camps on the main stem, and one thing that Katie, working with the Park Service, did this summer is went out to these camps early in the climbing season before anyone had used them. And at each of those camps, this is sort of a blow-up of one of those dots, sampled the snow in sort of an X pattern based out from where the camp would be once a camp is in place, and sampled what we assumed to be a sort of a control, the clean snow surface prior to the climbing season. And then did it again at the end of the or close to the end of the climbing season, after a bunch of camps had been there and climbers had used the area. And what she found is that these dots, which were placed systematically in an X pattern over a camp, no E. coli was found, or fecal coliform, in any of these spots radiating out from a heavily used climbers camp, except where those points happened to land in pee holes. And so one of the interesting things that we've learned here is that the disposal practices in terms of crevassing are pretty effective for keeping the snow surface clean, except that, interestingly, pee holes are turning up positive results for contamination. And I think that probably has to do not with urine being non-sterile, but sanitation practices involved in where those pee holes are. I think Mike Elz's work would suggest that E. coli would break down pretty quickly when exposed to UV. This would be a thin layer associated with the urine hole. But anyway, in the life cycle of the crevassed waste, I think we're doing a pretty good job keeping the snow surface clean where the climbers are spending their time. I'll also note that we didn't do this up at high camp or above that point, this testing protocol, and Roger promised that we'd deliver these results. An old turd was recovered this summer from 18,900 feet, high on summit day. Someone deposited it, we believe, close to a year ago, sat on the snow surface in a really cold place, was some guided party, whoever they are, bless their hearts, brought down someone else's turd for Katie to sample, and sure enough, after a year at the snow surface, we still get coliform and E. coli present and active from a turd that sat at a year in that very cold environment. So that's one interesting piece of data for us. It tells us that just freezing the waste is not really degrading it completely, at least, even in a fairly long time period. Yeah, it's right. Sitting right at this is in a place with high winds. I should have made that more clear. Yeah. Lots of UV radiation, cold temperatures, not buried deeply in the snow. I'm going to skip through this pretty quickly because it didn't work. I'll just tell you that the Park Service in 2002, prior to our work on the mountain, buried magnets in the pit latrines at base camp with the idea that they could return to those pit latrines over subsequent years and go down and sample that waste and see what's becoming of it as it's buried. When we started that project, were like, hey, did you ever go back and relocate them? And they said, no, I don't know, budgets or something. Didn't happen. And we said, well, we'll go look for them. And we made a prediction of where that waste over a period of time, based on the ice velocities and trajectories, would end up. Set up a little search grid around that area. You can see the little dots. And then Katie spent quite a bit of time with a magnetometer out there this summer. This is her results. This is intensity of magnetism detected at the ground surface in that grid. And basically what this is noise. And it's noisy because primarily because volcanic ash is magnetically active, and in 1992 and in 2009, so above and below those latrine pits that had the magnets in them, there's a thick ash layer from volcanic eruptions, and so they're masked, and those magnets will be melting out someday somewhere, but we weren't able to locate the latrines, unfortunately. One thing we can do, though, is do studies in the laboratory as well to try to augment these results. What I'm showing you here is results of some work that Katie did in the lab this past year. She's going to do more of this year. It's looking at the mean probable number, in other words, sort of counts of E. coli and total coliform in the blue and the green, respectively, after a number of freeze-thaw cycles in the laboratory. And this is on, not to steal your thunder, Mike, but Katie used her own waste, too. So how about a round of applause for that? Anyway, what you're seeing is, I think this is an important point, is that freeze-thaw is much more lethal for these pathogens than just freezing. Freeze-thaw cycles are important, and so we can infer, we haven't done enough work to confirm this in the field yet, but that when the waste emerges at the surface again, and is exposed to not only UV radiation, but a lot of freeze-thaw on the lower glacier, it's going to be fairly quickly, as it's exposed to that, rendered biologically inactive. But judging from that really cold turd that sat up high on the mountain and probably stayed frozen for quite a that. But how fast does it physically degrade in the ice, or once it melts out at the surface? We don't know. So we had a big search mounted just a week ago, where we were going to go down to the lower glacier to those predicted melt-out locations and see, has any waste melted out yet, as we're predicting it might have, because not many climbers go down there. So there could be these vast melted-out latrine pits down there that no one knows about. But it's been a nasty summer in Alaska, and there's still snow down there. So you're going to have to stay tuned for this question of, is the waste melted out yet? Can we then characterize its physical and its biological status once it melts out? If it is melted out, we're going to get the answers to that question. If it hasn't yet, because we're right on the borderline, then it's going to be more lab work is going to be the way that we can answer this question. Or go to one of the other places in the world where we know that crevassed waste is melting out currently, like the India-Pakistan border maybe is one place where we could probably find some human waste mixed in with is it 4 helicopters that are melting out of the glacier there? There are places we can go. We'd like to do it on Denali and keep it place-based, but we'll see if anyone knows a good place to sample emergent crevassed waste, we'd like to do that. Okay, and then finally, just work to come. Here's the full length of the Kahiltna Glacier. We've only been looking at this zone right here. This is the tail end down here of our flush toilet, where we're thinking the waste is going to emerge, and then that's the Kahiltna River. And we want to know, is there any contamination in that river even now, or could there be in the future? So planned for later this month, we're going to do water sampling in the Kahiltna River and also on supraglacial streams and ponds on the glacier surface. And then as a control, we need to check where these free water streams enter and go subglacially down on the lower glacier. We need to see, are they containing any contamination? Because if they are, then obviously we can't conclude that contamination here is from climbers up there. So we're going to be doing water sampling. Stay tuned for that. But I do want to tell you that there's this wasn't published, but it was presented at a conference, so maybe not many people are aware of this. But a fellow named Mark Skidmore at the University of Montana Bozeman and his student, I don't know her first name, but an undergraduate, somebody Whiteman, presented a poster. They sampled water downstream from the Glacier du Mont mine. I'm probably pronouncing that all wrong. In Switzerland, there's apparently an alpine hut at the head of that glacier, and they sampled the water coming out of the glacier terminus, and they found contamination from human feces in that water that's associated with the latrine pit and crevassing of waste at the head of the glacier. So there's reasons to think that this is an issue down here. Of course, it's a much bigger glacier, a much bigger river. If dilution is the solution to pollution, we might not actually have an issue there. We also have very few users of the Kahiltna water for drinking water or anything else that's downstream of that. And so some questions that this raises are sort of how comfortable is the Park Service with potentially contaminating a part of the glacier that very few people go to, or contaminating a water supply that very few people use. And that's not our job to answer that question, but we're trying to just characterize the impacts. In summary, we've got over 100 tons of waste certainly buried within the Kahiltna Glacier. We have emergence of that waste that is certain within some broad bracket of time. We have biological activity that's likely after emergence because simple freezing probably doesn't kill off all the bacteria, and an aesthetic impact of the melt out of that waste and the associated plastic bags and everything that it is uncertain, and that's one of the reasons we want to find these melted out pits. Next step, search for emergent waste later this summer. Improve our mass balance model. That's the accumulation and ablation that we are working with folks at the University of Alaska Fairbanks to improve our estimate of that. We're going to excavate some waste. Again, Katie buried some of her own waste on the near base camp, and we're going to pull that out next year and see how that looks. Maybe we'll have photos for the next Exit Strategies conference. I wasn't going to go there. You'll have to ask her in the question and answer. And again, this question about protozoa, because it may be that E. coli is pretty sensitive to freeze-thaw, but Giardia are rocking right down into the Kahiltna River. We don't know the answer to that yet.
Got a question. Did you factor in the depth of crevasses?
Yeah, great question. I didn't show it, but I did an analysis when I did that little numerical model of the effect of the depth of the crevasse burial. And the simple answer is it makes, relative to the other processes going on, the ice velocity and the mass balance curve, it makes very little difference. I think there's reasons aesthetically that it makes a difference, but as far as melt-out time, the effect that it has is well within the confidence interval of our estimates anyway. So not probably a big deal from the perspective of melt-out time.
If you're freezing, say vegetables, for example, the slower you freeze it, the larger the ice crystals.
Yeah, I did some research on that. They've done it in soils a lot with fecal coliform and E. coli, and they found that there is a bracket, a rate of, if it gets frozen really rapidly, not much cell damage occurs because it just kind of flash freezes. But there is a range that if it freezes a little bit slower, kind of some of that osmosis and stuff tends to damage, it forms little ice crystals and will damage the cells. So I set up my experiments based on freeze thaws that you might expect to see. And that's kind of an estimate. I'm going to have better temperature data after this season I've spent up there. And so I didn't do the really rapid freeze that you'd see up high. I did like about 5 degrees Celsius every 5 minutes or something. So it would cause damage to it. It's in that range I found in research. So
you'd mentioned the indicator organisms in feces that can be a problem, and E. coli and fecal coliform are often used. When you look at pathogen die-off in feces, bacteria tends to die very quickly, and it's not very robust. The protozoa, like you mentioned, are much more, but the one that is the very worst and the hardest to get rid of is the Ascaris lumbricoides, which is a roundworm egg. Now, I will offer this. In most healthy populations, you're not going to see, well, it's not known, but you're most likely not going to see this as much as you would say in a developing world situation. So that's good news. But if you're looking for the worst thing, it's the roundworm egg. And it has a really hard shell, and it is very resistant. And it can be dormant in soil for years and then take off again. So.
yeah, and I'd like to throw this out there. We've been trying to find a lab that would help me run a much more extensive run on that really old high camp poo, and no one's wanted to touch it because it's out of date and everything. So if anyone has any suggestions or knows of a lab that might be willing to help out with that, that would be great.
How are you standardizing the poo in terms of the length of time before it's deposited, how representative your poo is versus other people's poo, and are you standardizing the diet before you create the poo and so forth? Because there's a lot of variability in all these things, and if you're depositing low fecal poo to begin with, that's gonna have repercussions.
Right, there is, I've been working on standardizing all of that. I started out with fresh poo. I've kept one piece that I've remained frozen the entire time. It's still frozen, so I like to sample that at a later time to see if there's any difference between just being frozen solid and freeze thaws. And as far as diet, I haven't standardized that. I did an initial count before I started it, right when it was fresh, and I compared that with what's been published, what's a standard fecal coliform count in fresh feces, and so it's kind of a ballpark range right now, and I'm going to do much more extensive lab work also with UV cycles this fall.
I just wondered, with those timelines running from like 32 years to 450 years, if you're running any scenarios with those for climate change, accelerating those.
Yeah, great question. I think it's one of the reasons that correct me if I'm wrong, one of the reasons this has become a concern, or at least a high-profile concern for the Park Service is exactly this, the idea that probably the fern line, well, not probably, certainly the fern line is moving up the Kahiltna Glacier as a result of climate change, and that reflects the fact that the mass balance gradient is changing, it's getting warmer, and it is hence going to hasten the melt-out. The answer to your question is no. I did what in this context I would call a conservative analysis, which is using my best estimate of the current mass balance gradient. As I said, there's some collaborators are going to improve that estimate, but it'll still be an estimate of current conditions, and I think the interpretation then, because it's conservative, becomes a little more straightforward. It's that it's going to take that long or less. But by doing that, it would be another step one could do, but quite a bit more. It becomes more conjectural to say what might the climate be in the future, although it's safe to say it'll be warmer.